In addition to mass, a common way to talk about how much matter is in a substance is to talk about volume. So how much space is the substance occupying? So it's standard temperature and pressure, which we refer to as STP. The amount of space occupied by a mole is well known. So STP is considered 0 degrees Celsius and 1 atmosphere, and at STP 1 mole of gas, which is 6.022 times 10 to the 23rd gas particles or gas molecules, occupies 22.4 liters. So 22.4 liters is often referred to as molar volume. So this is a conversion factor that we can use. We know that 1 mole of gas is 22.4 liters of gas. This is a very useful relationship that we will use often in our course. So let's go ahead and use it. We want to determine moles based on volume and determine volume based on moles. In this first example, we want to find how many moles, target, of carbon dioxide are in 84.0 liters. So 84.0 liters, that looks like a starting point of CO2 gas. Now again, our conversion factor isn't listed in the question, but if we recall from the last slide, 1 mole of gas is 22.4 liters of gas. And carbon dioxide is a common gas. We exhale it all the time. So carbon dioxide, also known as CO2, is what we want to find something out about. This is going to be just a simple dimensional analysis for us. We can begin with our starting point, which is 84.0 liters of CO2. Then we can look at our relationship, which is liters to moles, and we know that our target is moles of CO2. So we're going to need to have moles of CO2 on top and liters of CO2 on the bottom. If we look at our conversion factor, that means we're going to use 22.4 liters on the bottom and 1 mole of gas on the top. So to solve this, I could multiply the top and then divide by the bottom, which winds up being 84 divided by 22.4, which gives me 3.75 moles of carbon dioxide. We can double check our units. We see that our liters of CO2 cancel. We wind up with only moles, and moles was our target. This is a very straightforward calculation for us, and the beautiful thing is that this conversion factor, 1 mole of gas equals 22.4 liters of gas, is true for any gas as long as it is at STP, so as long as it's at 0 degrees Celsius and 1 atmosphere of pressure. So now let's go the other way. What is the volume of 0.125 moles of nitrogen gas? So if we look at this one, volume is the target and moles is the starting point. Because this is a gas, we're going to use the same conversion factor we used above. 1 mole equals 22.4 liters. All right, now we're ready to solve this problem. We can begin with the starting point, 0.125 moles of N2 gas. We know that our target is liters of nitrogen gas. And we want to get rid of moles, so we're going to put those on the bottom. If we look at our conversion factor from moles to liters, we can go directly there. So we can say liters of nitrogen gas on the top. The conversion factor tells us 1 mole to 22.4 liters. And To solve this now, we're going to double check our units. Moles cancel. Liters match our target. We're good to go. So I'm going to multiply the top together and divide by the bottom. So I get 0.125 times 22.4 divided by 1, which is simply 2.8 liters of nitrogen gas. So it's pretty simple to go back and forth between moles and liters of gas using this conversion factor. All right, so we've learned two new tools today, and they can be summed up in something we call the mole roadmap. You guys have either received or will get a copy of this on cardstock. It is your best friend. You do not want to lose it because you are able to use it on tests and quizzes to help you solve mole-related problems. So it seems like there's a lot going on here. You have a little description to help you follow the map, but I'll walk you through it. So you have three different things that you are potentially looking at. So we're looking at either volume of gas, we're looking at representative particles, so molecules or atoms or formula units of some kind, or we're looking at mass. And over the last 2 days, we've done calculations considering all of these things. So in the middle, we have the mole. The mole is the common factor that can get us from grams to volume, or from volume to representative particles, or representative particles to mass. You can go any direction you like as long as you're using the correct conversion factor. So the conversion factor is given to you in between the steps, and it also tells you that if you are trying to go from mass to moles, you're going to have to divide by your conversion factor, and if you're going from moles to mass, you're going to have to multiply. If you're setting up your dimensional analysis table correctly, this should become obvious to you pretty quickly. Tomorrow, we are going to do clicker practice problems with these types of calculations, and we will practice using the mole roadmap to complete these calculations.